Okay, hi, this is a video to go through worksheet 5.2. So again, we try to have the key ideas at the front before we go through the answers. So the first formula that you need to remember here again is moment equals to force times distance. Okay, that is in worksheet 5.1. Now in worksheet 5.2, there's another thing you need to know is that if you know that the object is balanced, okay, or the beam is balanced, the anti-clockwise moment must equal to the clockwise moment. Okay, so here the force times distance on this side must be equal to the force times distance on this side. That's how you actually balance out. So let's try this here. Okay, here I have two forces. I know that it's equilibrium. Yeah, that's why it's balanced. Okay, this means it's balanced. So what is the weight for this one? So here I know that 90 times 50. I'm using centimeters. I'm not going to convert because it doesn't really matter here. 90 times 50 must be W times 30. Okay, so I can just put it in the equation here. 90 times 50 is equal to W times 30. So 90 times 50 divided by 30 equals to W. My W here is 150. Answer here is C. Now, okay, you might feel that this one is a bit too difficult for you as mathematics. Fine, you can just take it another way. Just take 90 times 50 equals to 4500. Okay, then the second formula will be 4500 divided by 30, and you get 150 also. Okay, so depends on which one you prefer. If you feel that it's easier to do everything together, you can do it this way. But if you feel that doing two together is too complicated, you might want to do the left side first, do the anti-clockwise first, then do the clockwise. You still get the answer. Okay? Question 2. So let's try the easier method because I think most of you didn't really like this one. So a student sits here, a student sits here, and what force must be exerted here to balance the seesaw? So let's consider this side first. We have 500 times 2, we get 1000 Newton meter on this side. So now this side must be 1000 Newton meter, and you have to divide by 4. Okay, so in this case my answer is D. Question 3. Okay, by this question you should get a hang of it. So here 6 times 4 is 24 Newton meter. Okay, then to find this F, I take 24 Newton meter divided by 3, I get 8 newtons. So the answer is D. Question 4. Okay, here, in this case, they don't give you distance, they give you the number of units. So you have to count. So in this case, this is 1, 2, 3. So there's 3 units here. So on this side, what is the moment? You have 200 times 3, you get 600. Alright, we ignore the units for now because I think we don't really need to know. So 600 here. So this man is 600. Okay, now this will confuse you a bit, but you just follow. This is the moment. So this is the moment divided by, this is the weight. So my distance is 1. So the distance is 1. From the pivot, I move to the right 1. So here the answer is A. Okay, so this one is a bit tricky because you tend to think that why would I take 600 divided by 600? But in this case, this one is the moment, which we calculated here. This one comes from the weight here. So that's why moment divided by weight gives me my distance. Okay, let's go to section B. Now section B here, how far must the sun be in order to balance the seesaw? Again, I'm going to use the simpler method so that it's easier for you to understand. I know that the plumber here weighs 800 newtons. I know the sun here weighs 600 newtons. Okay, so first I want to find the moment. It's equals to force times distance. It's equals to 800 times 3. And I get 2400 Newton meters. Okay, so this is one step, this is one mark. The next part I want to divide to find the length. So instead I'll write distance is equals to moment divided by force. So in this case my moment is 2400 Newton meters divided by 600 newtons. My answer is 4 meters. Answer. Not too difficult, right? Okay, next one. So this one is similar, just that this one, if you take note, this is a meter ruler. So it's 0 here, it's 50 here, it's 100 here. So what does this mean? What is the distance if I want to find the distance between the pivot and this force? So I'll take 70 minus 50, I get 20 cm here. Okay, so this distance from here to here, I do not know, which I need to find out. Okay, so how am I going to do this? Again, I'll take this side, I'll find the moment for this one. So moment is equals to force times distance. My force is 100 newtons. Multiply, I'm going to keep the cm. Okay, you'll see why it doesn't really matter in a short while. 2,000,102030 Newton centimeter. Okay, because Newton and centimeter gives me Newton centimeter. So this is a moment on this side. Now I need to divide to find the moment on this side. So I'll take distance equals to moment divide by force. So my moment is 2000 Newton centimeter divide by 70 newtons. My answer, I will get something, give me a moment, 2000 divided by 70, 228.5714 something. Okay, you will just round off to 28.6 cm. Okay, so that's not too difficult, right? Now, part B asks you to find the outward force acting on the pivot and explain your answer. So if you look at this, this is not really asking for movement anymore. This is asking for force. Okay? Now if you look at the diagram, right, you realize that the rod is not really moving upwards or downwards. So what does this mean? All the force acting downwards must be equal to the force acting upwards. So this is 70, this is 100. If I add together, the answer is 170. So the force acting downwards is 170. The upward force must be balanced. It must be 170 also. So how do I explain my answer? Okay, since there is no resultant force, the upward force must be equal to the downward force. Or if you want to use another word, they must be balanced. Okay? Alright, so let's move on to the last one. We are almost done. Just bear with me. Okay, here again we're just calculating the counterweight. So it's all the same formula all over again. So let's look at the left side. Our moment is equals to force times distance is equals to 6,000 times 15 meters. And my answer is 90,000 Newton meter. So if I know that my counterweight is this amount, I want to find the distance. So distance is equals to moment divided by force. So my moment is 90 Newton meters divided by 10,000 newtons. And I don't need to use calculator for this one. 9. Alright. So you realize that in this case, I don't really need to worry so much. I just need to make sure I calculate the moment, and then on the other side, I divide my force or I divide my distance. Usually I can get my answer. Okay, so this ends the video for 5.2. I hope it has been helpful.